Dear students, I welcome you to the course of Artificial Intelligence and lecture number 10. First of all, we will go through the previous lecture what we have done until now, and based on that we will continue today's lecture. So what we come to know that what is knowledge-based agent, what it means, what kind of features do we need for it. Then for that we need some kind of information to use it, and how this information will be used from the world or environment. We have different kind of environments as we studied in the earlier lectures, and then we have different kind of agents, and for that agent we need a knowledge-based system where we can keep the knowledge and then we can use this knowledge. Then we understand the example of Worm's World, which was a computer game, and then we try to understand it, and then we were understanding how the logic is used there, how the information, the knowledge we have, we take out the logic out of it using this different kind of statements, and then we try to understand how we will move from one place to another based on our logic, because we need some kind of proof, or we need to be sure from moving from one room to another room in case of Worm's World. So how we predict, how we understand, if we have some knowledge, if we have a knowledge of or for a room adjacent to another room, then for that case we need to understand how we will go to take out the logic. And then we understand syntax and semantics, that if we want to have collections of symbols which represent a word, then we call it syntax, and then if we take out the meaning out of it, what actually it means, and if we can summarize it, then we call it that this is a semantics. Then we also understand entailments or entailments. Then we were looking how it is going to help us for understanding between different syntaxes, and then how to take out the semantics. We also understand logic as a knowledge representative language. How many kind of languages do we need for representing a knowledge base. So we will also continue from the place where we left in the previous lecture, which is actually logic as a knowledge representative language. So what we will do today, we will understand logic, and then how many languages there are, and then we will try to understand propositional logic, which is one kind of knowledge-based language. Then we will see what's the pros and cons of propositional logic, and we will also try to understand first order logic, what it means and how it's different from propositional logic. Then we will see what's the syntax of first order logic and the basic elements of it, and then also we will try to understand atomic and complex sentences, how we can generate it using first order logic, and connection between quantifiers. We will use some quantifiers in first order logic, and then we will try to see what's the connection in between. First of all, we need to understand that for agent we can only get information or knowledge which the user is going to provide. So the reasoning agent often gets its knowledge about the fact of the world as a sequence of logical sentences, and must draw a conclusion only from them without independent access to the world. So in this point it's very clear that whatever agent will understand will be through user. What user is giving as a sentence, then the agent will take out the semantics out of it, or what's the information, what's the basic facts inside this sentence, and this will be understand, and it can be then perform some action out of it. Thus it's very important that the agent reasoning is sound. Sound in here means that it should be stable, it should be very clear and understandable, so it can be in a level of perfection that it can take out the complete understanding of any sentence. So here if we see we have a world and a user is giving this sentences which is actually knowledge to agent, and then the agent can take the conclusion out of it, and then it can see what's the actual meaning of this sentence is. So if it is complete and the agent can do this very easily, then we can say that this method that we are using for knowledge base, that we can make a knowledge base using the same structure. How many languages there are for knowledge base? So there is a propositional logic which we will understand today, inshallah, what it is. There are how many things there are related with it, so or what's the understanding of it. It says that there are only facts in the world, in the environment, and these facts are going to be used. These facts can be true or false, or it can be unknown. Then there is first order logic, which says that there are not only facts in the world, there are facts, objects and its relations and operations, and it can also be understood in that way, and it can be true, false, or it can be unknown. Then there are other languages. We will see a few of it, but today inshallah we will discuss propositional logic and first order logic. So first of all, we need to understand what logic is. We can also think of logic as an algebra for manipulating only two values, true and false. So what we can say logic is that it is exactly working like algebra. It can be either true or it can be either false. हम लॉजिक को सिंपल इस अंदाज में देख सकते हैं कि हमारे पास या तो उसका जवाब ठीक होगा या गलत होगा. हम कहते हैं कि लॉजिकल आंसर है, लॉजिकल बात हो रही है. इसका मतलब ये है कि हमारे पास कोई भी सिचुएशन होगी, कोई भी एक्शन हो रहा होगा, कोई भी सीन होगा, तो हम ये कहेंगे कि ये सीन या तो ठीक है या गलत है. तो अगर हम एग्जैक्टली इस मीनिंग्स में जवाब दे रहे हैं तो हम ये कह सकते हैं कि ये एक किस्म की लॉजिक है, लॉजिकल वे है, जो हमें बिल्कुल बाइनरी डिसीजन दे रहा है. कोई दो क्लासेस में हमें डिसीजन दे रहा है, तो हम ये कहेंगे कि ये लॉजिकल है. वी विल कवर नाउ propositional logic, which is the simplest kind, so it's very easy and easily understandable. What propositional logic is, why we use it, because we need to know a kind of we need to make a knowledge base where we can save, where we can keep our reasoning, our word information, and then based on that we can perform some action, so it can be used for making some decisions. So propositional logic consists of the logical value true and false. We can take as a T and F. Proposition sentences which are atomic. What it means, they must be treated as indivisible. It's not going to be many of it, so if it is atomic then it should be only one, so you cannot make subdivision of it, which is no internal structure. It has only one, like if we have only one value to compare with another value, so we will not divide it, so we have only one compare with 2 or something like this. It can be even single value, unary operation we can also perform, but the point is that whatever the sentence is, you cannot divide it into sub sentences, so it's always fixed. हम जो भी sentence लेंगे इसमें propositional logic में, वो हमारे पास एक सेंटेंस होगा जिसको हम डिवीजन उसकी नहीं कर सकते. हम ये नहीं कह सकते कि इसका मतलब ये भी हो सकता है, इसका मतलब ये भी हो सकता है. हम जो सेंटेंस लेंगे उसकी मीनिंग एक ही होगी, वो डिवाइड नहीं हो सकेगा, उसके सब क्लासेस नहीं बन सकेंगे. ऑपरेशंस हम कौन कौन से परफॉर्म कर सकते हैं? जिस तरह मैंने आपको बताया कि इसमें पिछले इस पॉइंट में हैविंग अ सिंगल लॉजिकल वैल्यू आइदर ट्रू और फॉल्स, ये भी हो सकता है कि वो सिंगल वैल्यू हो, वो या तो ट्रू होगी या फॉल्स होगी. मतलब ये कि हम ज़रूरी नहीं है कि कोई दो वैल्यूज कंपेयर करें, हम एक वैल्यू भी ले सकते हैं. ऑपरेशंस कौन कौन से हम कर सकते हैं? बोथ यूनरी एंड बाइनरी. हम किसी भी सेंटेंस के ऊपर या यूनरी ऑपरेशन परफॉर्म कर सकते हैं या बाइनरी. सो आइदर कैन अप्लाई. When applied to a logical value, yield logical values. So it can also give us a logical value. The usual operators are and, or, not, and implies. So these are the normal operators that we are going to use in a propositional logic. How it is now? So the propositional logic syntax, how we will use it for knowledge base. Propositional logic is a simplest logic illustrating basic idea. What's the basic idea in this situation? A proposition symbol P1, P2, etc. are sentences. So if we take P1 as a propositional sentence 1 and propositional sentence 2, then how we can use it? If S is a sentence, then S not is a sentence. Negation not. So if S belongs to any proposition or a sentence, then we can say that S not is also a sentence. This means that if even we take a negation of it, it's also a sentence. So this is a unary operation. If S1 and S2 are sentence, then S1 and S2 is also a sentence. Conjunction we can use also the operation, or we also call it and. हम देखते हैं यहाँ पर कि हमारे पास अगर sentences आते हैं, तो अगर वो sentence है जो कि लॉजिक की बेस पे है, प्रोपोजिशनल लॉजिक की बेस पे है, और वो क्या है? वो एक फैक्ट है, वो एक हकीकत है. तो अगर हम उसकी निगेशन भी ले लें तब भी वो हकीकत ही रहेगी, तब भी वो सेंटेंस ही रहेगी, सिर्फ हमने उसकी निगेशन ले लिया. और अगर सेम इसी तरह हमारे पास अगर एक सेंटेंस है S1 और दूसरा सेंटेंस है S2, तो इन दोनों को कंबाइन करने के बाद भी हम ये कहेंगे कि ये फिर भी सेंटेंस ही है. ठीक है. If sentence 1 and if S1 and S2 are sentence, then S1 or S2 is a sentence. Disjunction or. So in this situation we are using or operator. So if S1 is sentence, so for sure S2 is also a sentence, then we can use or in between as operator. So if S1 and S2 are sentences, then what S1 implies to S2, it's also possible. In this situation, if S1 and S2 are sentence, then S1 bidirectional to S2, so it can be in both direction. We will go through some example and then you will understand it more easily. So what we are going to do, we will make a truth table of it. Logic, like arithmetic, has operation which applies to one, two or more values, opponents. So if we are using propositional logic, in that case it's like arithmetics, and then we will make a truth table of it, so we can apply it on one or two or more opponents. So this is very basic understanding of arithmetics. A truth table lists the result for each possible argument of opponents. order is important. X opponent Y may or may not give the same result as Y opponent X. So here it's mentioned that the order in this situation matters because it's not important, it's not necessary that X opponent Y will give you the same result as Y opponent X. So this is very important, which one you are putting it first and which one is the second one, because it can alter the result. The rows in truth table list all possible sequences of truth value for n opponents. So if we have n opponents, then for that the rows are actually giving the possible sequences, if it is true, false, or it is false, true, or if it is false, false, or if it is true, true. So what it is, it will give you this sequence of possibilities, because we understand, we fix it in the beginning that propositional logic is based on true, false, so we can only give this solution. Specify a result for each sequence, and then for sure if there are multiple opponents, then we will say that there will be a sequence as it is in x, y, and then y, x, so it can be different, and then for that all possible results will be mentioned here. Hence there are 2 power n rows in the table for n opponents. So if we have one opponent, then there will be only 2 rows, because n is 1, and then we will have 2 rows. If there are 2 opponents, then the rows will be 4. So this is very easy to understand that that the rows will be as much as the rows will be actually power of 2 power of n. यहाँ पर बेसिक अंडरस्टैंडिंग कर रहे हैं कि ट्रूथ टेबल हम कैसे बनाएंगे. सिंपल, अगर हमारे पास ओपोनेंट्स हैं तो वो ओपोनेंट्स की जो वैल्यूज़ आ रही होंगी, रिजल्टिंग वैल्यूज़ आ रही होंगी ट्रू फॉल्स की फॉर्म में, तो हम सिंपल उसको अपने ट्रूथ टेबल में रखेंगे. और ट्रूथ टेबल में हमने सीक्वेंस का ख्याल रखना है, क्योंकि सीक्वेंस आपके रिज़ल्ट को अल्टर कर सकता है. और फिर हमने ये देखना है कि जो रोज़ होंगी वो हमें पॉसिबल सीक्वेंस दे रही होगी. एन एक्चुअली नंबर ऑफ ओपोनेंट्स हैं, कितने ओपोनेंट्स हम यूज़ कर रहे हैं. तो अगर ओपोनेंट्स 1 है तो हमारे पास रोज़ 2 बन रही होंगी. अगर ओपोनेंट 2 हैं तो हमारे पास रोज़ 4 बन रही होंगी. अब हम जाते हैं चंद एग्जांपल्स की तरफ ताकि आपको सही समझ आ जाए. देयर आर 4 पॉसिबल यूनरी ऑपरेशन. वी कैन परफॉर्म 4 पॉसिबल unary operation. Unary means single operation. So if we have a single opponent x, then how many rows there will be? 2 power 1, and then there are 2 rows. So we can make only 2. Only the last of these negation is widely used as a symbol not for the operation. Mostly we use this x naught, but there are also other operations that we can use it as a unary operation. So if we have a x and the value is true, then constant true will be true, constant false will be false, and then identical or identity will be true, and then the negation will be f. So if there is a true, then there will be a false. In case of false is also the same. Constant t true will come again true, constant f will come f, whatever. If there is, the constant t will give you always t, and whatever here is, the constant f will give you f. Identity will give you the same thing, as if there is f, then it will be also f. And the negation will always be completely reverse. If there is F, then it will give you true. Now we are moving to some binary operation. Here are the binary operation that are traditionally used. Normally we use this one. So if we have X and Y operand, and then we have a sequence, so we take it as a Y as a true false, and then X as a true and false. Then what will happen in using AND operation? First of all, we need to note this notice in particular that material implications are implies only approximately means the same as English word implies. So it's not 100%, but it is approximation that this R which implies means. Any other binary operator can be constructed from a combination of these along with unary not. So if we use unary not operation, so we can also construct other operation by combining different binary operation in here. So as we know that if we have true and true, then AND will give you true and OR will also give you true. We will use this symbol for OR and this symbol for AND, and then for implies we use R, true, and then bidirectional we also use it as a TM, use T. If there is a true false, or if we go from this direction, then it's F, false and true, then AND will give you false, because if either of it is false, then AND will give you false. And if there is OR, then in any case, if there is one true, it will give you true. So if one is false, the other will also become false. And in case of bidirectional, if one is false, the other will also become false because it's bidirectional. We also call this one as XOR. If you know that if we have both the same, if there is a true, it will give you true. If there are both false, then it will also give you false. So we also call it XOR operation. And if there is a difference between it, then it will also give you false. So you can understand this truth table, and it's for logical operation. So what kind of expression can we use? All logical expression can be computed with some combination of AND with this symbol, or this symbol and NOT with this symbol operation. For example, logical implication can be computed in this way. So if we want to take a negation of X, then we can say that it is in this situation. We can use it that if there is a true, negation of true is false. If we have X true, so negation of true is false. If we have false, negation of false is true, and then if we have false, negation of false is false. And then we can combine it. We can also take negation of X and Y. So both we can use it, but what's the negation of it? So in this case it's true. If we have true and false, then it becomes false. If we have false and true, then it becomes true. If we have false and false, then it will become true. So if we see here, this equivalent or operation are the same as if we are using it X naught or X not operation and operation. If we combine both, then it becomes similar to the equivalent operation. Now we will go through some pros and cons, some positive and negative points of propositional logic. We understand in the basic understanding was that propositional logic is declarative. We need to declare it into some fixed symbols, and then we can use only that symbols because to understand and to keep it in our knowledge base. Propositional logic allows partial, disjunctive, negated information, unlike most data structure and databases. So in this case, we can have the information based on some disjunction, some negation. So this is also one positive aspect of propositional logic, that we can keep this kind of information instead, as if we have it in a data structure, we cannot keep most of this operation and this kind of data. So in this case, it's quite helpful. Propositional logic is compositional. How it is? We can use combinations of different opponents, and then we can combine it. We can use it in this case. So if we take an example, meaning of B11, if there is a breeze, then if we use a AND operator, we say that P12 is actually, there is a pit in P12. If we are taking as a Worm's example, is derived from meaning of B11. If there is a breeze in one room, then and there is a pit in 1-2. So we can take this meaning just by understanding the basic knowledge. If we have this knowledge that there is a breeze in 1-1, so there is a possibility that there is a pit in 1-2. So that's why we can combine this. So we can make a compositional sentences. Meaning is propositional logic is context independent, unlike natural language where meaning depends on contexts. We know that most of the time, if we are talking about something, we need to understand the context of it. There is some context, and then we take the meaning of any sentence, because if we don't know the context, maybe we can take wrong impression, wrong understanding of it. So in propositional logic, it's context independent. We don't have any context of the previous situation, or of the state, or of the sentences. So we just keep only the current situation. So it is a kind of negative point in this situation, but anyhow the basic one we can count it on as a negative point is propositional logic has a very limited expressive power. So it's very difficult because it has very limited symbol, limited possibilities that you can express everything, unlike natural language, that is cannot say pits cause breeze in adjacent squares, except by writing one sentence for each square. So we cannot say this, that if there is a breeze coming out, this means that there is a pit adjacent to it. We cannot say this because we need to have only in form of true and false. So if we are using propositional logic, our language symbols are very limited. We cannot represent most of the things in our propositional logic. Or if we want to do it, then we will need to do it in every situation, in every state, and that will be very difficult. It will make our life very difficult to make all the sentences for all the rooms. So as we have some problem in propositional logic, we will move to first order logic. In propositional logic, as I mentioned, that propositional logic assumes the world contains facts. So there are only facts, and these facts can be either true or false. But what happens in first order logic, like natural language, assume the world contains object, relations, and function and operations. So we can also say functions are like properties. We can use it as a properties, or we can also say it's functions. So in first order logic, now we have multiple things. How we can say it? We think about everything as an object. So if we have an object, objects are like people, houses, number, colors, baseball game, wars, or any other kind of things. We call it as an object. And then what will happen if we have objects? Then there will be relationship between different objects. So the relationship we can define as red, round, prime, brother of, bigger than, part of, comes between. So there can be many possible relations. Then what are the functions? Father of can be father of, best friend of, one, more than, plus. These are what? Actually, these are functions. So if we have a sentence which says evil King John ruled England in 1200 century, so we can take this as a, if we take this in a first order logic, then we can make objects. What are the objects? John, England, and 1200. And then what are the relation? Ruled, he was ruling on England. And then we can say properties. If we are not using functions, then what are the properties of king? Evil, and he was also a king. So हम यहाँ पर बेसिक अंडरस्टैंडिंग करते हैं फर्स्ट ऑर्डर लॉजिक की, कि प्रोपोजिशनल लॉजिक में हमने सिंपल ये कहा था कि हर एक चीज़ जो है, वर्ल्ड जो है, वो फैक्ट्स हैं, फैक्ट्स का मजमुआ है. आइदर वो ट्रू हो सकती हैं, फॉल्स हो सकती हैं. लेकिन वहाँ पर हमारे पास काफ़ी मसले आ रहे थे, क्योंकि हर एक चीज़ तो हकीकत में इस तरह नहीं है. इस वजह से हम वो लैंग्वेज फॉलो नहीं कर सकते थे. काफ़ी डिफ़िकल्टीज़ आ रही थी. कुछ सिचुएशंस में तो बेहतर है कि हम उसी को फॉलो करें, क्योंकि वो हमें बहुत इजीली अंडरस्टैंडिंग हो जाती है उसकी. लेकिन फिर हमने देखा कि अगर हम फर्स्ट ऑर्डर लॉजिक यूज़ करते हैं नेचुरल लैंग्वेज की तरह, तो उसमें हम देखते हैं हमारे पास ऑब्जेक्ट्स होते हैं, मोस्ट ऑफ द टाइम ऑब्जेक्ट्स होते हैं, और उन ऑब्जेक्ट्स के आपस में कुछ रिलेशंस होते हैं. अगर लोग हैं तो लोगों के आपस में कुछ रिलेशंस होंगे, वो एज अ फ्रेंड्स होंगे, वो एज अ पेरेंट्स होंगे, एज अ सिबलिंग्स होंगे. इस तरह के बहुत सारे रिलेशंस हो सकते हैं. फिर उनके फंक्शंस होंगे कि वो किसी का भाई है, वो किसी का बेस्ट फ्रेंड है, वो किसी का वालिद है. तो इस तरह के फंक्शंस होंगे, और उन फंक्शंस को वो कैसे परफॉर्म करेगा. हमने अगर एक छोटा सा सेंटेंस हम लेते हैं, evil King John ruled England in 1200 century, then how we can take the objects relation and properties of it. We can make this out of many sentences. So logic in general, what it is, what exists in the world. We know that there are many things which exist in the world. This is true. So propositional logic, how we will use this propositional logic? Fact hold or do not hold. Whatever facts there are, they can exist or they cannot exist. But in first order logic, objects with the relation between them, that they hold or not hold. So there are objects, they have a relationship in between, and these relationship can either hold or it cannot hold. So now if we go to the table that we discussed in the first few slides, so we have propositional logic, and now we can say that it's only facts here, and in first order logic we have facts, objects, and relation, and these both can be either true or false or can be unknown. What is the syntax of first order logic? Basic elements. So constant symbol, we can use some symbols which we say that they are constant, we cannot change it because they are objects. Stands for object, that is King John 2, UCL, or any other kind of objects that we can use, they are called constant symbol. Predicate symbol, what is predicate symbol? Stands for relations. As we say that the objects will have relations, so we can say that there is a predicate symbol in between brother Richard. So Richard and John are brother, so we can say that this is one predicate symbol. We can use it. Greater than, so 3 is greater than 2. It can also give you a result as a true or false. Function symbol stand for function. We use different kind of function. Square root of 3, left leg of John, so John the king. So what we can say that we can use different kind of functions. हम 3 बेसिक एलिमेंट्स हैं हमारे पास. एक को हम कहते हैं कांस्टेंट सिंबल जो ऑब्जेक्ट्स के लिए यूज़ होगा. हम डिफरेंट ऑब्जेक्ट्स को जिस तरह हम रिप्रेजेंट करेंगे उसको हम कहेंगे कि कांस्टेंट सिंबल है. प्रेडिक्टेड सिंबल क्या होगा? जो रिलेशनशिप है उनका आपस में ऑब्जेक्ट्स का, उसको हम कहेंगे कि प्रेडिक्टेड सिंबल है. और फंक्शंस जो भी हम उसके ऊपर एक्स्ट्रा परफॉर्म कर रहे हैं कि या स्क्वायर रूट ले रहे हैं या उसको एडिशन कर रहे हैं या इस तरह की कोई चीज़, तो वो हम कहेंगे कि ये उनके फंक्शंस हैं. सिंटैक्स ऑफ फर्स्ट ऑर्डर लॉजिक. बेसिक एलिमेंट्स, वी नीड टू हैव डिफरेंट elements. There are a lot, but we just collect few of it. Constant, we have King John 2, UCL, or different kind of constant objects we can use. Then we have predictors, brother, greater than, less than, these kind of thing. Functions, we have square root, left leg off. So there are different kind of functions we can use. We have variables, x, y, a, b. There are different kind of variables. Then we need to have connectives, different kind of connectives. Not implies to, greater than, equal to, these kind, not equal to, implies to, or bidirectional, we can call these connectives. Then we have equality. What equal means? If we have it on both sides, they have the same meaning. And then quantifiers for all, and there exist some, so we can use these kind of quantifiers. What is relations? We will understand that some relations are properties. They state some facts about a single object. Round, ball is round, prime, so 7 number if it is prime. So we have some properties. We all the relations, we cannot call it that they have some specific relation meaning. We can also say that they can be properties, because if you remember in the King John, we say that we can also use properties instead of functions. An array relation state facts about 2 or more objects. Married John, comma Mary, larger than 3, comma 2. So we can also say that we can use an array relation in between 2 things. This relationship can be by mean more than 2 or 2. We can use it. Some relations are functions. Their value is another object. So if we are using some functions, this function can be a relation, and this relation will give you one object, because if we add plus 2 and 3, it will give you one object. Father died, so then we can say that if he is a father or if he is not. If we go for atomic sentences, what it means? Atomic sentences, because we will use this kind of terminologies. So for that we need to understand what term is. Term is actually a function, and we can use term 1 until term n, or constant or variable. A logical expression that refers to an object. Left leg of Richard. So यहाँ पर हम ये बताना चाह रहे हैं कि टर्म जो है वो एक्चुअली फंक्शंस होंगे, वो भी कोई कांस्टेंट जो होंगे हमारे पास ऑब्जेक्ट्स, उनको रिप्रेजेंट करने के लिए जो एक्सप्रेशंस हम यूज़ करते हैं, तो हम ये कहेंगे कि ये हमारे पास डिफरेंट किस्म के टर्म्स हैं. इसके दो किस्में हो सकती हैं. कांस्टेंट सिंबल्स हो सकते हैं, टेबल, कंप्यूटर, ये डिफरेंट किस्म के जो ऑब्जेक्ट्स हैं उसको हम यूज़ कर सकते हैं, और ये एज अ फंक्शन सिंबल भी यूज़ हो सकते हैं. लेफ्ट लेग, square root and plus, there are different kind of functions that we can use it as a term. So when we say term, then it's a logical expression refers to the object. ये एक किस्म की abbreviations हम यूज़ करेंगे. हम एक किस्म की जो अल्फाज हैं उनको यूज़ करेंगे किसी भी ऑब्जेक्ट को रिप्रेजेंट करने के लिए, या उसकी तरफ हम जब रेफर करेंगे. एटॉमिक सेंटेंस क्या होगी? प्रेडिक्ट्स term 1 until term n, or term 1 equal to term 2. An atomic sentence is formed from a predicted symbols followed by a list of terms. So if we have a list of terms and we try to use some kind of symbols, then we say that this is atomic sentence. Some examples are here. Larger than 2,3 is false, because we have two terms, two objects, and then we want to find out what's the answer of it. In this situation it gives us false. Brother of Mary, Pity, so it's also false, because Mary is not brother of Pity. Married father Richard, mother John could be true or false. So we don't know if father of Richard and mother of John they are married together or not, because John is a brother of Richard, but in this situation we are not sure about their parents. So if they are married, or if they are from the same mother father. So in this situation we say that atomic sentence is what we predict from different terms, different objects. Function do not state facts and from no sentences. There is a possibility that the functions they are not going to represent any sentence. Brother Pitt refers to John, his brother, and is neither true nor false. So brother Pitt refers to John. In some situation, if we are using this, then we don't know the reality. That's why we are not sure in this situation. So brother of Pitt, brother of we also call this as a function. So in the last line, it can be a binary relationship, or we can also use it as a multiple of functions. So in here we have binary Pitt and brother Pitt. So this is a function, but this one is one object. So in this situation we want to find out if he is a brother or not. So in this situation we can use multiple of terms. Now we can make complex sentences. We make complex sentences with connectivities, just like propositional logic. If we are using propositional logic, as I mentioned in the earlier slide, that we can use opponents, and then if we have different opponents, we can, if we add the negation, we can also make different complex sentences. So in the same way we can also here make different or complex sentences. So here is a negation, and we say that if there is a binary relation for brother, because brother will be in between two objects or two person, so that's why we need to have two inputs of it. One object is Richard and other is John, but we want to find out if Richard is a left leg or not, because this is left leg is one rank in the last kingship or kingdom system. So function, this is one kind of function, we can also call it. And then we have connectives, which is and, or this is or, Democrat or Bush. So we can combine this as another sentence. So we can combine different sentences and we can use different logical operations, and then we can make complex sentences. हम अगर इसके और एग्जांपल्स देखें तो ब्रदर रिचर्ड, जॉन, ये हमारे पास बाइनरी है. हम देखना चाहते हैं कि क्या ब्रदर जॉन और रिचर्ड ट्रू हैं कि नहीं. तो हमने यहाँ पर इसकी एंड कंडीशन लगा दी, किंग रिचर्ड और किंग जॉन. हम यहाँ देख रहे हैं कि क्या रिचर्ड जो है क्या वो किंग है या जो जॉन है वो किंग है. किंग जॉन इम्प्लाइज टू नॉट किंग रिचर्ड. जॉन जो है, अगर तो जॉन किंग है तो फिर किंग रिचर्ड जो है वो जॉन नहीं होगा. लेस देन प्लस 1 2 4. सो हम ये चेक करना चाहते हैं कि क्या 1 2 को हम प्लस करें और क्या वो मतलब 3, क्या 3 4 से लेस देन है कि नहीं. एंड ग्रेटर देन 1 2, क्या वो फिर 1 और 2 को हम आपस में चेक कर रहे हैं कि क्या वो ग्रेटर देन हैं कि नहीं एक दूसरे से. Semantics are the same as in propositional logic. हम जो semantics हम यूज़ कर रहे थे propositional logic में, हम सेम उसी तरह यहाँ पर भी फर्स्ट ऑर्डर लॉजिक में भी यूज़ कर रहे होंगे. यहाँ पर वेरिएबल्स क्या होंगे हम वो भी देखते हैं. अभी पर्सन जॉन इज़ ट्रू और फॉल्स बिकॉज वी गिव इट एज अ सिंगल आर्गुमेंट जॉन. अब जब हम पर्सन देखते हैं कि क्या जॉन पर्सन है कि नहीं है, तो वो हमें एक सिंगल वैल्यू देगा, या ट्रू होगी या फॉल्स होगी. तो ये हमारे पास एक वेरिएबल हो गया. वी कैन बी मच मोर फ्लेक्सिबल इफ वी अलाउ वेरिएबल्स which can take one value in a domain, that is all person x, all integer I, etc. अब अगर हम बजाय इसके कि उसमें एक वैल्यू दें जो हमें ट्रू फॉल्स में आंसर दे, तो हम उसमें अगर मल्टीपल वेरिएबल्स देना चाहें ताकि हमें पता चले कि हम सब के लिए यूज़ करना चाहें तो क्या वो हमारे लिए पॉसिबल होगा कि नहीं, तो ये हमारे लिए बेहतर तरीका होगा क्योंकि हम फर्स्ट ऑर्डर लॉजिक में ये कर सकते हैं. ऑल पर्सन एक्स, ऑल इंटीजर आई को हम यूज़ कर सकते हैं कि जितने भी एक्स पर्सनस हैं उसकी कोई प्रॉपर्टी हो, या जितने भी इंटीजर हैं उनकी कोई प्रॉपर्टीज़ हम चेक करना चाहें. एग्जांपल यहाँ पर ये है कि कैन स्टेट रूल लाइक अ पर्सन, एक्स implies to has head x, or integer I implies to integer plus I comma 1. So we say that if a person x is a person if it has a head. If x has a head, then we say that it is also we call it as a person. So we can use x as a for all, or we can also use x as a not for all. So in this situation, if we are using a universal quantifier, you will understand much more easily. This is a symbol for all, so allows us to make statement about all objects that have certain properties. If we are going to use this symbol, this is going to make make our language very easy, so we can combine a lot of things in one sentence. Can now state journal rules. So for this situation, we need to understand few basic rules. For all x, king x implies to person x. So all the kings, they are all x kings, they need to be persons. For all x persons, x implies to has head of all x. So x is a variable, and for all x, if they will be person if they have a head. So in this situation, for all I, integer implies to integer plus I into 1. So if I is any kind of value which is a number, if we can plus it with 1, then this means that it is also integer. Note that for all x, king and person x is not correct. So we cannot use and in between for all. This would imply that all object x are king and are people, because we know that if we are using and, then this means that all kings are persons, and we can also say that all persons are king, which is not true. For all king x implies person x is the correct way to say this. So we can only use this way because all kings x are persons. And we can also say existential quantifier, which means there are some x such that. So this is the basic symbol that we will use it, and we can also use this for many situations. Allows us to make statement about some object without naming it. So as we are using variables, so we don't need to name it, and we can use a lot of sentences. There exists x, king x. So we can say that there are some x, that they are king. There exists x lives in John Castle X. So if there is a person John who he can also live as a person is living in castle, so John can also live in castle. In case of integer, there exist integer that are greater than I, 0. So for sure there exists some. Note that and is a natural connective to use with there exist, and implies is the natural connective to use with for all. So this and we use it for existential quantifier, and if implies we use it mostly in our there exist. अब हम देखते हैं कि हम जितने भी क्वांटिफायर्स हैं क्या उनको हम कंबाइन कर सकते हैं. तो क्योंकि हम फर्स्ट ऑर्डर लॉजिक की तरफ जा रहे हैं और हमने ये देखा कि हम सेंटेंसेस को यूज़ कर सकते हैं ऑब्जेक्ट्स की प्रॉपर्टीज़ और उनके फैक्ट्स और उनके जो फंक्शंस हैं और की बेसिस पे और उनके जो आपस में रिलेशनशिप्स हैं. तो हम यहाँ पर ये भी देख सकते हैं कि हम जो क्वांटिफायर्स हैं उनको आपस में कंबाइन भी कर सकते हैं. फॉर ऑल एक्स देयर एग्जिस्ट वाई लव्स एक्स एंड वाई. सो for sure For everyone, all X, there is someone Y who loves them. This is very simple. ہم ان دونوں کو کمبائن کر سکتے ہیں. ہم یہاں پر بھی ایگزسٹینشنل کو بھی کمبائن کر سکتے ہیں. دیر ایگزسٹ وائی فار آل ایکس لوز ایکس وائی. دیر از سم ون وائی ہو لوز ایوری ون. سو اٹس ان another way around. Clear with the parentheses. If we are using parentheses, then it's very easy to understand that there exists y, and then we use for all x loves x into comma y. This x loves y, but for all of it. So this means that if we come out from the parentheses, then we can understand that there exist some y's. Connection between quantifiers, we can use different kind of connection. Asserting that all x have properties p is the same as asserting that does not exist any x that doesn't have the property p. So we can also use different kind of connection, and this connection can be in bidirectional. So we can say that there exists some p, or we can, if we look to this example, for all x likes x comma 271 class. So what implies in bidirectional, not there exists not x, and there not like x 271 class. So we can use all x they like 271 class, but if we want to use existential, then we put not in it. In effect, for all is a conjunction over the universe of object. There exists is a disjunction over the universe of the object. Thus De Morgan rules can be applied. ہم یہاں پر دیکھتے ہیں کہ ان دونوں میں کیا ڈفرینس ہے. بیسیکلی ہم جب بھی فار آل یوز کریں گے تو ہم کنجنکشن یوز کریں گے, اور جب بھی ہم دیر ایگزسٹ یوز کریں گے تو ہم کہیں گے کہ دیر از اے ڈسجنکشن. تو اس وجہ سے ہم ڈی مورگن لا کو بھی یوز کر سکتے ہیں. ڈی مورگن لا میں سمپلی کیا ہے کہ جہاں پر اور ہے اس کو اینڈ میں لے, اور جہاں پر اینڈ ہے اس کو اور میں لے, اور اس کے ساتھ نگیشن لگا دیں. تو ہم دیکھتے ہیں یہاں پر پی اینڈ کیو ہے, تو ہم جب نگیشن لگاتے ہیں ہر ایک کے ساتھ درمیان میں اور لگا دیں, اور پھر اوور آل نگیشن لے لیں, تو وہ امپلائز ٹو ہو جائے گا, وہ ایکول ہو جائے گا. ہم سیم اسی طرح پر اگر ہمارے پاس پی اور کیو ہے, اور کیو ہے, تو بھی ہم اگر اس کو ریورس کر دیتے ہیں اور ساتھ میں نگیشنز لگا دیں, تو ہم یہ کہیں گے کہ یہ ایگزیکٹلی سیم چیز ہے. سیم اسی طرح ہم دوسرے ڈی مورگنز کے جو لا ہیں اس میں بھی کر سکتے ہیں. اب ہم جب جاتے ہیں جنرلائز ڈی مورگن رولز کی طرف, تو اس میں بھی ہم یہی کریں گے کہ ہم اس کے ساتھ نگیشن لگا دیں گے ہر ایک کے ساتھ انڈیویجولی, تو وہ بھی ہمیں سمپلی اس کا ریورس دے گا. اور ساتھ میں ہم کریں گے کیا کہ ہم جو ہمارے پاس ایگزسٹینشنل اگر تو فار آل ہے تو ہم اس کو دیر ایگزسٹ میں کنورٹ کر دیں گے, اور سیم اگر ہمارے پاس دیر ایگزسٹ ہے تو ہم اس کو کنورٹ کر دیں گے فار آل میں, اور اس کی ہم نگیشن لے لیں گے. تو اس کا مطلب یہ ہو کہ ہم ڈی مورگن لا کو اپلائی کر سکتے ہیں جو ان کی ریلیشنز ہیں آپس میں. اب میں کنکلوڈ کروں گا آج کے لیکچر کو کہ آج ہم نے کون کون سی چیزیں کور کی. ہم بیسک دیکھ رہے تھے کہ لاجک کیا ہے, اس کی انڈرسٹینڈنگ دیکھی ہم نے. پھر ہم نے کچھ پروپوزیشنل لاجک دیکھی کہ ہم اگر کوئی بھی ورڈ ہے اس کو کنورٹ کرنا چاہتے ہیں سینٹینسز کی فارم میں, اس کو ڈیٹا بیس نالج بیس میں ہم رکھنا چاہ رہے ہیں, تو اس کو ہم کیسے کریں گے. پروپوزیشنل لاجک کی بیس پہ ہم کر سکتے ہیں. اس میں یہ بتایا گیا کہ ہر ایک چیز جو ہے ایز اے فیکٹ ہے وہ یا ٹرو ہے یا فالس ہے. اس وجہ سے ہم نے انڈرسٹینڈ کیا, ڈفرینٹ ایگزامپلس دیکھی اس کے, پھر ہم نے ٹروتھ ٹیبل دیکھا ہم اس کو کیسے ڈیزائن کریں گے. اب ہم نے اس کے بعد دیکھا کہ اس کے جو پروز اینڈ کونس تھے پروپوزیشنل لاجک کے وہ کیا تھے. ہم اسی کو پھر ہم نے بیس بنا کر ہم فرسٹ آرڈر لاجک کی طرف گئے کہ ہم کیونکہ بہت ساری چیزوں کو ہم بائنری ڈیسیژن نہیں لے سکتے، اس کی ٹرو فالس میں نہیں کر سکتے، اس وجہ سے ہم اس کو فرسٹ آرڈر لاجک میں لاتے ہیں. اب فرسٹ آرڈر لاجک میں ہم دیکھتے ہیں کہ ہر ایک جو ورلڈ ہے اس ورلڈ میں ہر ایک چیز کو ہم ایز آبجیکٹ دیکھتے ہیں، پھر اس کے کچھ ریلیشن شپس ہیں آپس میں اور کچھ فنکشنز اور پراپرٹیز ہیں اس کے. تو پھر ہم نے یہ دیکھا اس کے بعد کہ سینٹیکس جو ہے فرسٹ آرڈر لاجک کا وہ کیا ہے، کون سے ایلیمنٹس ہمیں چاہیے ہوتے ہیں، کون سے آپریشنز ہم یوز کر سکتے ہیں. اس کے بعد ہم نے یہ دیکھا کہ ہم ایٹامک اور کمپلیکس سینٹینسز کیسے جنریٹ کرتے ہیں. ایٹامک سینٹینس کا کیا مطلب ہے، اس میں جو ہمارے پاس ڈفرینٹ قسم کے ٹرمز ہے اس کا کیا مطلب ہے، ہم کیسے کمبینیشنز کر سکتے ہیں اگر ہمارے پاس آپریشنز ہیں ڈفرینٹ. پھر ہم نے یہ دیکھا کہ کنجکشنز بٹوین کوانٹیفائرز، ہمارے پاس جتنے بھی کوانٹیفائرز تھے دیر ایگزسٹ فار آل. ہم نے یہ دیکھا کہ ان کے آپس میں کیا ریلیشن شپ ہے، ہم ڈی مورگن لا کو کیسے یوز کرتے ہوئے ہم جرنلائز کر سکتے ہیں کوانٹیفائرز کے اوپر. تو آج ہم نے یہ انڈرسٹینڈ کیا اور انشاءاللہ ہم نیکسٹ لیکچر میں اسی ٹاپک کو کنٹینیو کریں گے اور ہم کچھ اور نالج ریپرزینٹیٹیو لینگویجز کو انڈرسٹینڈ کریں گے. اب تک کے لیے اتنا ہی، انشاءاللہ نیکسٹ لیکچر میں ملیں گے. اللہ حافظ.